Hi, this is Victor Morganti from Fact Engine. Today we're going to create an object role model inside the Boston Conceptual Modeling software from beginning to end, and at the same time look at the exploitable aspects of object role modeling which allow you to visualize your database as a property graph schema or a entity relationship diagram. And we'll also look at where Fact Engine sits over the top of models inside Boston, and where using Fact Engine we can query a database or a data lake or a data warehouse, either in the cloud or a local database, an on-premise database, using controlled natural language. So we're going to use a reference model that I've already created because I know that I can hook that model up to a database that I have on my local machine. Boston is available for your Windows desktop, or you can run Boston through your web browser as a hosted service by Fact Engine, or you can host Boston on your own intranet, and users can use Boston through the web browser on your on-premise intranet through a browser. So we're using Boston locally on a Windows machine here today, and let's get stuck straight into it. So I've got a model open in the Model Explorer already, and it's a model for cinema bookings, and it's an SQL-Lite database behind this model. Some attribution. The original model this was based on was developed by Data Constellation and shared on GitHub by Data Constellation. So we've already got a object role model, which I'll show you now, and the cinema bookings model is for people being able to book seats at a cinema to watch a film at a session. Now, the object role model itself is quite busy, so the best way to view models I find in Boston is as a property graph schema. So let's get a feel for the model that we're going to create. So we have people, so a person node type, and if I control click on that I can see the properties of a person, so person ID, their age, date of birth. I've got a secondary age there, and login name. If I look at a seat, for instance, a seat has a cinema ID, a row number, a letter, and a section name. If I look at section, section just has a property section name. So it's a property graph schema where people can make bookings for one or more seats for a session to watch a film at a cinema, and where seats are in rows in the cinema and seats are in sections. So it's a very simple conceptual model, and we know that in Boston we can take the property graph schema, select an item in there, and so a node type, and morph to a corresponding entity relationship diagram if we've got one set up. So, and we do. So this is a entity relationship diagram for the same schema. So cinema, session, booking, people, films, rows, sections. And the only difference is that our entity relationship diagram has a many-to-many join table between booking and seat, where a booking can have many seats and a seat can have many bookings. You don't see this particular item in a property graph schema. So let's click on, say, booking, and we're going to morph back to our property graph schema. Now, there are three main modeling languages in Boston, and we can go from the property graph schema back to our object role model. Now, the secret sauce of Boston, and even Fact Engine sitting over the top of Boston, is that in essence all models inside Boston are object role models which have ostensible views as a property graph schema or a entity relationship diagram. And this is coming to be known as visualizing your database as a relational knowledge graph. So here's a entity relationship diagram, so a relational knowledge graph, and this is a property graph schema, and it's a property graph schema of our underlying model. So we want to see how to create a object role model. So I'm going to minimize the Cinema Bookings SQLite database there or model, and I'm going to go to the home page as if we just started Boston, and to create a model there's three options. You can click on this button here, so add a model to Boston. You can go to models, right click and add a model, or you can say session new model. So I'm just going to click on this button here and we're going to create a new model. Now the icon for a model is a database, and you might wonder why a conceptual model has a database for its icon. And the reason for that is that if we go to say our first model and go to Fact Engine, we can write a query such as which seat has a booking that is for a session that is to watch the film Rocky. Now, unless I'm mistaken, there'll be a seat that has a booking for a session to watch the film Rocky in this database, and there is. So there's 2 seats. So in Cinema 1, row 1, letter A and 20A have bookings on these dates to watch the film Rocky. So we have an icon of a database against our model because, for instance, this model here has the icon of SQLite because it's hooked up to an SQLite database, and we've just run a query against the SQLite database. Here's the SQL query that we just ran based on our Fact Engine query language. Now let's go back to creating our model. Models have pages, and the default page type is an object role model. I'm just going to change the name of that to main, and we have a blank page. So on the right hand side inside Boston we have a toolbox, and in this case the toolbox is for object role modeling. We have different views of the model. So we have a model dictionary, which at this stage is empty. We have a properties grid, which we can look at the properties of various items in the model, and our toolbox. We'll use the toolbox first, and then we'll show you how to use the virtual analyst when you're creating an object role model. So let's start with film. So we're going to select an entity type for film, and we've created an entity type. I just clicked on the canvas and film is red, and the reason it's red will appear in the error list, and it says the entity type requires a reference scheme error, so entity type film. So basically an entity type without a reference scheme is like a table without a primary key in object role modeling. So let's click on that, go to its properties and find reference mode, and we're going to give it a reference mode of ID. So now when I click on the canvas, the entity type is blue, and we have film is uniquely identified by its ID. We can expand the reference scheme and see that film, and here's a fact type, film has a film ID, and a film ID has a film. These two lines here above the roles of this fact type say that it's a one-to-one relationship, so film ID uniquely identifies film, and this double bar internal uniqueness constraint says that film ID is the provides the primary reference scheme for film. So I'm going to hide the reference scheme, and I'm going to view the model dictionary. So I've effectively just clicked on this tab here and gone to the model dictionary. I'm going to refresh that, and we've got an object type film, we've got a value type film ID, and we've got a fact type film has film ID, and we've got those couple of constraints that I just showed you. But also, if we go to the entity relationship view, we've automatically created a table in our entity relationship view, film, that has and you can see a hash symbol there, a primary key of film ID. Now I'll add a page to our model, so I'm going to add an entity relationship diagram, and I'm going to call that ERD main. I'm going to open that, and I'm going to drag the film entity or table to that page. So as we create our object role model, we're automatically creating our entity relationship diagram, and it's even better than that, we're also creating our property graph schema. So I'm going to add a property graph schema page and call that PGS main, property graph schema main, and automatically now in the model dictionary we can see a node type film, and I can drag that onto the page, and there's our film node type. So as we create our object role model, we're automatically creating our entity relationship diagram and our property graph schema. So I'll try and speed things up from here so that we can get to the goodies of using FactEngine as quickly as possible. So I'm going to go back to the toolbox, and I'm going to drag over an entity type for a cinema. Now that'll be red. I want to give it a reference mode, so we're going to uniquely identify our cinemas by cinema ID. I'm going to go back to the toolbox and create an entity type for row. I'm going to leave that red at this stage. I'm going to create an entity type for seat. I'm going to leave that red at this stage. Seats are in sections, so let's have a section. I'm going to give section a reference scheme, and I'm going to select .name. So section is uniquely identified by its section name. We can expand the reference scheme and view that. Excuse me. So there's our reference scheme. A section, this dot here says a section must have a participate in this fact type. A section has a section name, and a section name is of a section. It's a one-to-one relationship, and the double bar says that the section name provides the primary reference scheme for section. So I can hide that reference scheme. If I go over to the ERD view, go to the model dictionary, we can see that section, excuse me, let's delete that. Section has a primary key of section name, and if I display the uniqueness constraints, primary keys and foreign keys, I can see I've got PK there. So the short name for this primary key is PK, and section has a primary key of section name. So I'm going to turn that off, and we just see the table. Now, to hurry things along a little bit, what I'm going to do is I'm going to go to the model configuration for our SQLite database. I'm going to take the connection string, go back to our model we've just created, which we're also going to call cinema bookings, and I'll call it number 2, and go to its model configuration. I'm going to set its database type to SQLite, give it a connection string, test that connection, it's successful, apply that, and now Cinema Bookings 2 is hooked up to a database, and we can start to query it already because we've created some tables. So I'm going to say which section and hit go on that, and here's our section. So the public section, the gala section, and the deluxe section. So in the model we've just created, we've created a entity type with a primary reference scheme of .name. So section is identified by its section name. That's created a table. Section has the column section name, which is the primary key. We also have a property graph schema view of section, and we've been able to go to the database and actually look at the data in the database. Now we'll try and do something a little bit tricky here. It should work. Let's select that table, go to view table data, and you can use Boston pretty much as if it were a database productivity tool, such as an Access database, where we can actually view data and edit the data inside this database table data toolbox. So there's our 3 sections: public, gala, and deluxe. And we can probably do the same for film, except we haven't got a film name. So let's give film a name. I'm going to do that using the virtual analyst, and I'm going to say film has 1 name. Now this is going to create a fact type without me having to use the toolbox. So film has 1 name, and I'm going to hit enter on that. Brianna, the virtual analyst, says, would you like me to create a value type for name? I'm going to say yes. Would you like me to create a fact type for film has name? Yes. Normally I would call this value type film name, but just because of the way the database has been created, I'm just going to leave that as name at this stage. So excuse me, we have a film has a name, and I can create a reverse reading for that using the ORM reading editor and say name is for film, and hit enter on that. So we have a forward reading, film has name, and we have a reverse reading, name is for film, and we can see that here. And we're going to set this up as a one-to-one relationship, so we can use the film's name to uniquely identify film. Name is red, so it's going to appear in the error list, and down the bottom here it says data type not specified error for value type name. So we need to give name a data type. We'll go to its properties, and now we're looking at the property grid, and we'll give it a data type, and we're going to say text, fixed length, and let's say 200. So that's now blue, and we've given the value type a data type. And the reason we would do that is because, of course, in our table with a column name, we need to have name having a data type in our database. So if I look at what's known as the ORM verbalizer, so the ORM verbalization view, when I click on name, I can see that name is an attribute, its data type is text fixed length, its data length is 200, and here's the reading for that, for the fact type that created that column. Each film has at most one name. Each name is for at most one film. Now, we don't really want that to be at most one. We want that to be 1. So there's a small error there, because that should read film has one name, because that's a mandatory constraint on there. So forgive me for that. This fact type should read film has one name here, which it does inside the ORM view. When I'm looking at the attribute view in the ERD, it's got the wrong reading. So let's trust the ORM view on that, where we're saying each film has one name and each name is for at most one film. Okay, so we've got films, we've got a cinema. We want to give cinema a name. So let's go to our virtual analyst. Cinema has one cinema name, and I'm going to take a shortcut here. I'm going to define its data type in the virtual analyst. So I'm going to say text fixed length, say 100. Okay, so I've written cinema has one cinema name, written as text fixed length 100. So I'm going to hit go on that. It's created the cinema name for us. And would you like to create a fact type for cinema has cinema name? And I'm going to say yes. So our cinema has a cinema name. Now, unless I'm mistaken, I should be able to go to, say, film and view its table data. And in our database, we've got a film ID and we've got a name. So Rocky, Grease, Dr. Zhivago, Inception, Speed. Similarly with cinema, we can view the table data, and we have cinemas 1, 2, 3 and 4 with the names Great Western Cinema, Northern Star Cinema, Watson Cinema and the Rialto, so just Rialto. So our object role model is getting there, and we can speed things up a little bit now. So let's click on row and cinema and hit the R key. That's a shortcut for creating a fact type, and we're going to say that a row is in a cinema, and we're going to say it's mandatory that a row is in a cinema. Setting up this internal uniqueness constraint effectively says that each row, and we're going to give this a reading, is in one cinema. So let's do that. So let's click on that and go to our ORM reading editor and say row is in cinema, and I'm going to change the fact type's name there to row is in cinema, and we'll give it a reverse reading. So cinema has row, and there's a reverse reading. So here's our fact type reading, row is in cinema and cinema has row. Now a row has a row number. Now I'm going to use the virtual analyst for that. So row has one row number, and we're going to say that's written as numeric. Let me find I'm going to give that a unsigned small integer. So row has one row number, written as an unsigned integer, small integer. And it's created the value type for us. Do we want to create the fact type? Yes, we do. Now, we can create a reverse reading. So row number is for row, and now we've got a reverse reading. So row has a row number, and a row number is for row. This is still red because we haven't given it a primary reference scheme. So let's give row a primary reference scheme, and we're going to go back to the toolbox, and we're going to create a special type of reference scheme here. We're going to give it a external uniqueness constraint rather than these bars above roles, which are internal uniqueness constraints, and we're going to drag from cinema to the role joining row number, click on the canvas, select the properties for that external uniqueness constraint and change it to is preferred identifier. Now when I click on the external uniqueness constraint and go to the verbalization, it says for each cinema and row number, at most one row is in that cinema and has that row number. And basically what we're saying is our database can have multiple cinemas, which it does, and the combination of cinema ID and row number identifies a row. So I should be able to look at the database data on that. So I'm going to view the table, and sure enough, here's a whole bunch of rows set up already in the database. So cinema 1, row number 1, cinema 1, row number 2, cinema 1, row number 3, cinema 2, row number 1, etc. So if I go to my ERD view, look at the model dictionary and select row, I have rows that are in cinemas, and our two hash symbols here identify the primary key for row as cinema ID and row ID. And the particular type of entity relationship diagram that we use in Boston has predicates, so we can read row is in cinema and cinema has multiple rows. So as quickly as I can, I'm going to set up the same sort of relationship for seat. So I'm going to hit the R key. I'm going to say that a seat must be in a row. I'm going to give that an internal uniqueness constraint, and using the virtual analyst, I'm going to say a seat has one letter written as text fixed length 1. Okay, so seat has one letter written as text fixed length 1. It's created the letter value type for us. It's going to create the fact type, and you know when you go to a cinema that you want to talk about I'm in row 1 letter A, but because we've got multiple cinemas in our database, we want to talk about row 1 letter A in cinema 1. Now we do that by going back to the toolbox, selecting an external uniqueness constraint, putting that across the role that joins row and the role that joins letter, and going to the properties and set that up as the primary reference scheme. And when let's just give that a fact type a reading. So seat is in row, and we're going to say yes. We'll change the fact type name to seat is in row, and we're going to say row has seat. So there's our reading for our fact type. If I click on the external uniqueness constraint, I can see that for each row and letter, at most one seat is in that row and has that letter. But when I look at our entity relationship diagram, I'll see something a little bit extraordinary, which is that seat has a primary key across cinema ID, row number and letter. I should be able to go to the database and look at the data, and we're saying that cinema ID 1 in row number 1 has letter A, cinema ID 1 and row number 1 has a seat with letter B, cinema ID 1 with row number 1 has a seat with letter C, etc. Let's set up the relationship between seat and section name. I might be able to do that directly from the entity relationship view. Let's give that a go. Right, and we've done that, so we've added section name to our seat, and we're effectively using Boston now as if it was ER Win, so entity relationship Win, the software where we've got an entity and another entity, and we've just created a relationship. Now, if I click on that, it's actually a fact type behind the scenes, and I can say it's given us a relation seat relates to section, but I'm going to say seat is in section. I'm going to change the fact type's name, and we're going to say section has seat, and that's been reflected in our relation in our ERD view for our model. So we're getting there. We're probably going a little bit slower than I would like, so I'm going to close there. I think you've got a decent feel for how to create an object role model inside Boston. If I continued on with this, I would end up with this object role model, where you can see where we set up a cinema, a row, seats and sections. We would go on to then create a fact type for booking, where a person booked a session, and where a booking has multiple seats, and where a session is a fact type between film, date, time and cinema. We might just do that in our model just to get a feel for how to do that. So I'm going to use the virtual analyst to do that. I'm going to say session is where film is showing at cinema on date time. So unless I'm mistaken, that's going to create a ternary fact type for us called session. So it's asked me first, would you like to create a value type for date time? I'm going to say yes. Would you like me to create a fact type for film is showing at cinema on date time? I'm going to say yes. And it's called it session for us. I'm going to show the fact type's name. Let's give date time a property, and we're going to say that it's temporal, date and time. I'm going to give that a many to many to many internal uniqueness constraint across all 3 rows, and we've created our session fact type, which I'm now going to objectify. And when you objectify a fact type, you effectively turn it into a table, and I should be able to view the table data for that. I'm going to do that from the ER view. So I'm going to go to the model dictionary. We've just created session. Here's our session. Our primary key is across film ID, cinema ID, date, time, and we should be able to view the data for that. So cinema ID 1 is showing film ID 1 at date, time, etc. At a particular date, time. Now in Fact Engine, because I've created that data already, I should be able to say which film is showing at which cinema on which date, time. Now I believe I should be able to just hit go on that and get some results back, and I have. So Rocky is showing at Cinema 1 on that date. Greece is showing at Cinema 1 on that date. If we wanted to know the name of the cinema, we could say, and that cinema has which cinema name. Okay, now I should be able to hit go on that, and now we've got the actual name for the cinema. So we've got the cinema ID. ID 1 is Great Western Cinema. Rocky is showing at Cinema ID 2, which is the Northern Star Cinema on this particular date. So that's an introduction to creating a object role model inside the Boston Conceptual Modeling software. We've seen that the entity relationship diagram view is automatically created for us. As quick as you can blink, if you've already hooked up your model to a database, you can view the data in your database. And we know that we have a property graph schema view of our model. So if I say I dump display as PGS node, I'm going to reload this page. It'll come up differently, I believe. We have seats that are in sections, seats that are in rows, and that's pretty much all we've set up at this stage. I'm going to save that, close it and reopen it. I apologise, I had problems with the property graph schema page, so I've just recreated it, and here's what we've created so far for our property graph schema view. So a session involves a film, and a session is for a cinema. We've said that seats are in rows in cinema, and a seat has a section. So that's our property graph schema view. Here's our entity relationship diagram view. Here's our main view for the model that we've created, the object role model. And in our original model, this is what the complete object role model would look like for our cinema bookings database. So thanks for watching a long video, but that gives you a broad stroke introduction to the Boston Conceptual Modeling software. Boston is available for your Windows desktop or through your browser in the cloud from Fact Engine server, or you can host Boston on your intranet as a secure private installation of Boston to do your conceptual modeling. So thanks for watching. I hope you enjoy the video. If you like the video, please hit like and subscribe, and I'll see you in the next video.